We are familiar with this shape. This is a circle. We have also learnt about the different terms related to circle. Let us revise them again. Look at the figure alongside. O is the center of the circle. Which is the radius of the circle? Segment OA is the radius of the circle and segment PQ is the diameter of the circle. Segment RS is the chord of the circle. Now, look at the circle with center P. Which are the points on the circle? Points S and T are the points on the circle, whereas points A, P and J are in the interior of the circle. Points B and K are in the exterior of the circle. Now, let us answer the questions from exercise 90. Question 1. Observe the figure alongside and write the names of the center, a diameter and a chord of the circle. Answer. In the given figure, C is the center of the circle, segment PQ is the diameter and segment RQ is the chord of the circle. Question 2. Write the names of the points in the interior of the circle. Answer. Points C and M are in the interior of the circle. Question 3. Write the names of the points in the exterior of the circle. Answer. Points N and K are in the exterior of the circle. Question 4. Write the names of the points on the circle. Answer. Points R, P, S and Q are on the circle. Let us now learn some more terms related to circle. Let us begin with the circular region. A, B and C are points on the circle. P, Q and R are points in the interior of the circle. All the points, that is points on the circle as well as points in the interior of the circle together make the circular region. Here, all points like A, B, C, P, Q and R together is the circular region. Here in the figure, the shaded portion is the circular region. Let us now see what is meant by a segment of the circle. Look at the figure alongside. Segment AB is a chord of the circle. As you can see in the figure that the chord divides the circular region into two parts. Each part is called a segment of the circle. Here, the shaded portion AYB is the major segment of the circle. The unshaded part AXB is the minor segment of the circle. Let us move forward to the semicircular region. In the figure alongside, segment AB is the diameter. We know that diameter divides the circular region into two equal halves. So, the two segments formed by the diameter AB are called semicircular regions. Here, segment AXB and segment AYB are semicircular regions. Let us now learn about angles in the same segment. See the figure alongside. There are two angles in minor segment. Angle APB and angle AQB are angles in the minor segment. These angles are in same segment. Now, measure the angles in the segment with a protractor. Let us first measure angle APB. It is equal to 50 degrees. Now let us measure angle AQB. It is equal to 50 degrees. We will find that angle APB is equal to angle AQB, that is 50 degrees. It means that the angles in the same segment are congruent. We can draw several different segments and verify this property. Let us now solve a sum from exercise 91. Question 1. In the figure, measure of angle XYZ is equal to 100 degrees. And then, what is the measure of angle XPZ? Solution. In the given figure, angle XYZ and angle XPZ are the angles in the same segment. We know that the angles in the same segment are congruent. Therefore, measure of angle XYZ is equal to measure of angle XPZ. Measure of angle XYZ is given as 100 degrees. Therefore, measure of angle XPZ is equal to 100 degrees. Let us now see the property of angles in a semicircular region. Segment PAQ or PBQ and segment PXQ are semicircular region in this figure. Angles PAQ and PBQ are in the semicircular region. Let us measure the angles PAQ and PBQ in a semicircular region with a protractor. Measure of angle PAQ is equal to 90 degrees. Similarly, measure angle PBQ. We will find that measure of angle PAQ is equal to measure of angle PBQ, that is 90 degrees. It means that an angle in a semicircular region is a right angle. We can verify this property in circles of different radii. Let us now solve another sum from exercise 91. Question 2. In the figure, segment PQ is a diameter. Hence, write the names of the right angles. Solution. In the figure, it is given that segment PQ is the diameter. So, segment PSQ and segment PRQ are the semicircular regions. We know that the angle in the semicircular region is a right angle. In segment PSQ, angle PSQ is a right angle, and in segment PRQ, angle PRQ is a right angle. Hence, angle PSQ and angle PRQ are the right angles. Let us now look at the property of angles in the major and minor segment. In the given figure, angle PSQ is the angle in the minor segment and angle PRQ is the angle in the major segment. Let us measure angles PRQ and PSQ using a protractor. Let us first measure angle PRQ. It is equal to 70 degrees. Now, let us measure angle PSQ. It is 110 degrees. It means that the angle in the major segment is an acute angle and the angle in the minor segment is an obtuse angle. Let us solve one more sum from exercise 91. Question 3. Look at the figure and answer the following questions. 1. Name the angles in the minor segment. Solution. In the given figure, segment PRQ is the minor segment. Angle PAQ and angle PBQ are the angles in the minor segment. 2. Name the angles in the major segment. Solution. In the given figure, segment PDQ is the major segment. Angle PDQ and angle PCQ are the angles in the major segment. 3. Name the pairs of angles in the same segment. Solution. The pairs of angles in the minor segment PRQ is angle PAQ and angle PBQ. The pair of angles in the major segment PDQ is angle PDQ and angle PCQ. Let us solve some more problems from exercise 91. Question 4. Fill in the blanks. 1. The two segments of the circle made by a diameter are called semicircular regions. 2. The measure of an angle in a semicircular region is 90 degrees. 3. all points on the circle and all points in the interior of the circle together form the circular region. Question 5. Are the following statements true or false? Correct the wrong ones and write them again. 1. An angle in a semicircular region is an acute angle. Answer. False. An angle in semicircular region is a right angle. 2. The angle in the minor segment of a circle is a right angle. Answer. False. An angle in the minor segment of a circle is an obtuse angle. 3. The angle in the major segment of a circle is an obtuse angle. Answer. False. An angle in the major segment of a circle is an acute angle. 4. Angles in the same segment of a circle are congruent. Answer. True. Question 6. In the figure, segment SK is a diameter. Hence, write the measures of the following angles. 1. Measure of angles STK. 2. Measure of angle SMK. Solution. In the given figure, segment SK is a diameter. Therefore, STK and SMK are the semicircular region formed due to segment SK. We know that angle in a semicircular region is a right angle. Hence, measure of angle STK is equal to 90 degrees and measure of angle SMK is also equal to 90 degrees. Now, let us solve the sums from problem set 2. Question 1. In the figure, segment AB is a diameter. Write the names of right angles. Solution. In the figure, it is given that segment AB is a diameter. So, segment APB and segment AQB are the semicircular regions. We know that the angle in the semicircular region is a right angle. In segment APB, angle APB is a right angle, and in segment AQB, angle AQB is a right angle. Hence, angle APB and angle AQB are the right angles. Question 2. In the figure, FX is a chord. Write names of 1. The minor segment. Answer. In the given figure, FAX or FOX is the minor segment. 2. Angles in the minor segment. Answer. Angle FAX and angle FOX are the angles in the minor segment. 3. The major segment. Answer. In the figure, FBX or FCX is the major segment. 4. Angles in the major segment. Answer. Angle FBX and angle FCX are the angles in the major segment. 5. Pairs of congruent angles in the same segment. Answer. In the minor segment, angle FAX is congruent to angle FOX. In the major segment, angle FBX is congruent to angle FCX. Children, we revised terms like center, diameter and chord of the circle. Also named the points on the circle, points in the interior and in the exterior of the circle. We also learned some new terms such as circular region, segment of the circle, the semicircular region, angles in the same segment, angles in a semicircular region, and angles in the major and minor segment. Here point O is the center of the circle. Segment AB is the diameter of the circle. It is a segment passing through the center of the circle and joining any 2 points on the circle. A circumference is the outer boundary of a circle. Segment OD is the radius of the circle. It is a segment joining a point on the circle to the center of the circle. It is half the length of diameter, that is, radius is equal to diameter upon 2. It means diameter is twice the length of radius, that is, diameter is equal to 2 multiplied by radius. A circle has infinite radii and diameters. Chord is a segment joining any two points on the circumference of a circle. Segment PQ is the chord. A diameter is the longest chord in a circle. Remember, all diameters are chords, but all chords cannot be diameters. Now let us proceed towards the first exercise of this chapter. On the basis of the given properties of circle, let us solve the first exercise 19. Question 1. Fill in the blanks. Segment OD is a radius. Segment AB is a diameter. Segment PQ is a chord. Length of segment AB is double that of segment OD. Because segment AB is the diameter, segment OD is the radius. And we have learnt that diameter's length is double that of a radius. Look at the next figure on your screen and write the names of the center of circle, the radius, chord and diameter. Solution. 1. C is the center of the circle. 2. Segment CD, segment CM, segment CL are the radii of the circle. 3. Segment RT and segment LM are chords of the circle. 4. Segment LM is the diameter. Now let us take a look at the last figure given in the exercise question 3. True or false with respect to the properties of circle. So, let's write the answers. 1. Segment TS is not a chord. False, because it is touching 2 points on the circumference, and according to a chord's definition, segment TS is a chord. 2. Segment KM is a chord. True, because as we have learnt, segment KM is a diameter and diameter of any circle is the longest chord. So, segment KM is also a chord. 3. Segment CK is a radius. True. We can clearly see it in the figure. 4. Segment KM is not a diameter. False. We have already discussed this for statement 2. Now, before we start with the new topic, let me explain you some basic concepts. 1. Congruent segments or sides means segments whose lengths are equal, and congruent angle means angles whose measures are equal. 2. Perpendicular means making an angle of 90 degrees. 3. Bisect means to divide a segment into equal parts. 4. Perpendicular bisector of a segment means bisecting the segment making a 90 degrees angle. Let us now deal with the distance between center of a circle and a chord. In this figure, we can see the circle with center O, chord segment AB, segment OM perpendicular to chord AB. Here the length of the perpendicular OM is the distance of the point O from the chord AB. Now let us learn about the property of the perpendicular drawn from the center of the chord of a circle. A. The perpendicular drawn from the center of a circle to a chord of the circle bisects the chord. Let us see the figure. Since segment PT is perpendicular to chord LM, therefore length LT is equal to length TM. B. Segment joining the center and the midpoint of the chord of a circle is perpendicular to the chord. Here, point T is the midpoint of chord LM of a circle with center P. Therefore, segment PT perpendicular chord LM. Now let us study the second property of the distances between the center of a circle and congruent chords of the circle. From this figure, we can see a circle with center O, segment ON perpendicular chord PQ, segment OM perpendicular chord AB. A. Congruent chords in the same circle are at an equal distance from the center of the circle. If chord PQ is congruent to chord AB, then length of segment OM is equal to length of segment ON. B. Chords of same circle which are at equal distance from the center of circle are congruent. In this figure, if length of segment OM is equal to length of segment ON, then chord AB is congruent to chord PQ. Let us learn about the last property of the angles made at the center of the circle by congruent chords of that circle. Infer that given chord AB is congruent to chord CD, O is center of the circle. A. Congruent chords of same circle make congruent angles at the center of the circle. That is, if chord AB congruent to chord CD, then angle AOB is equal to angle COD. That is, angle AOB is congruent to angle COD. B. In other words, chords of the same circle which make congruent angles at the center of the circle are congruent. That is, if angle AOB is congruent to angle COD, then chord AB is congruent to chord CD. Now, let us revise all the properties once again before solving a few more examples. Look at the figure of the circle with center O and chord PQ congruent to chord AB. Chord AB is at a distance of 4 cm from the center of the circle O. Now, using the second property, let's find the distance of chord PQ from the center O of the circle. Solution. We have learnt earlier in the property of chord that congruent chords are equidistant, that is, at equal distance from the center of the circle. Therefore, distance of chord PQ from the center O will be the same as distance of chord AB from the center O, which is equal to 4 cm. Therefore, distance of chord PQ from the center O is equal to 4 cm. Students, always remember to mention the property that has been used to solve the problem. Now look at the figure alongside on the screen. We have a circle with center O with the two congruent chords. Chord AB is congruent to chord CD and measure angle AOB is equal to 120 degrees. We have to find measure angle COD. Solution. Now chord AB is congruent to chord CD. By using property that congruent chords of the same circle form congruent angles at the center of the circle. Therefore, measure angle COD is equal to measure angle AOB. Therefore, measure angle COD is equal to 120 degrees. Now let us solve the exercise 20. A chord of a circle is 30 cm long. Its distance from the center is 8 cm. Find the radius of the circle given. We can see that length of chord of the given circle, that is segment QR, is equal to 30 centimeter. Its distance from the center is 8 centimeter. So we will draw segment PM perpendicular to segment QR at point M to show distance and length of segment PM, which is equal to 8 centimeter. Therefore, we have to find length of radius PQ. Solution. Using the property that a perpendicular drawn from the center of circle to the chord bisects the chord, we get length of QM, which is equal to length of MR. But length of QR is equal to 30 centimeter. Length of QR is equal to length of QM plus length MR. But segment QM is congruent to segment MR. Therefore, length of QM is equal to length MR is equal to half the length of QR. Therefore, length QM is equal to length MR is equal to half into 30 is equal to 15 centimeter. In right angle triangle PMQ, using Pythagoras theorem, we can find length of radius PQ. Length of PQ square is equal to length of PM square plus length of QM square. Therefore, length of PQ square is equal to 8 square plus 15 square. Therefore, length of PQ square is equal to 64 plus 225, which is equal to 289. Therefore, length of PQ is equal to square root of 289, which is equal to 17 centimeter. Answer: radius of circle is 17 centimeter. Given segment OM is perpendicular to chord AB. Length of segment AM is equal to 1.5 centimeter. Find the length of segment MB and segment AB. Solution. Segment OM is perpendicular to chord AB. Thus, by using the property that the perpendicular drawn from the center of a circle to a chord of the circle bisects the chord. Thus we can say length of segment AM is equal to 1.5 centimeter. Therefore, length of segment MB is also 1.5 centimeter. Segment OM bisects the chord AB at point M. But length of AB is equal to length of AM plus length of MB, which is equal to 1.5 plus 1.5. Therefore, length of AB is equal to 3 centimeter. Answer. Length of segment MB is equal to 1.5 centimeter and length of segment AB is equal to 3 centimeter. As you all know, the outer boundary line of the circle is termed as its circumference. In the figure of the circle, we can see that a point P is shown on the circumference of a circle. Let's briefly cover up the concepts of radius and diameter. Look at the screen. We can see a circle with center O. Segment OT is the radius of the circle. As we can see, length of segment AB is equal to 2 times length of segment OT. It means diameter is twice the length of radius. Always remember the symbols of the radius, diameter, circumference, etc. while solving problems. We denote the radius of a circle as the single alphabet R, diameter as D, and circumference as C. We can say D is equal to 2 into R, and if diameter is twice the radius, then radius is half of the diameter. So we can write R is equal to half into D. These two formulae are very important. Always remember the basic formulae of the circle. Now we will deal with an important Greek letter pi, which is a constant. So let us discuss the relation between the circumference of a circle and diameter of the circle. The ratio of the circumference of any circle to its diameter is constant. This constant is an irrational number. It is represented using the Greek letter pi. Therefore, we can say circumference upon diameter is equal to pi. Therefore, C is equal to pi d. But we know that d is equal to 2 into r. Therefore, C is equal to 2 into pi into r. The approximate value of the constant pi is equal to 22 upon 7 or 3.14. As we know, pi is an irrational number, and the decimal form of the irrational number pi is 3.14159265358, which is a non-terminating, non-recurring number. We normally use the value of pi up to 2 decimal places, which is 3.14. So, we say that 3.14 is approximate value of pi and 22 upon 7 is very close to 3.142. So, normally the value of pi is taken as 22 upon 7. Now let us solve a few examples taking the value of pi as 22 upon 7. Example 1. A circle has a diameter of 7 cm. Find its circumference. Given. Diameter of the circle is equal to 7 cm. We have to find the circumference. Solution. We know two formulae of circumference, namely C is equal to pi into D and C is equal to 2 into pi into R. In the above example, distance is given. So we will use the formula C is equal to pi into D, where pi is equal to 22 upon 7. Therefore, by substituting the values of diameter and pi, we get C is equal to 22 upon 7 into 7. Now, cancelling 7, we get C is equal to 22. Answer: circumference is equal to 22 cm. Let us solve exercise 28, example 1. A circle has radius of 3.5 cm. Find its circumference. Given. R is equal to 3.5 cm. We have to find the circumference. Solution. When radius is given, we should consider the formulae for circumference as C is equal to 2 into pi into R, where pi is equal to 22 upon 7. We get circumference is equal to 2 into 22 upon 7 into 3.5. That is, circumference is equal to 2 into 22 into 0.5. Circumference is equal to 22 cm. Answer is circumference is equal to 22 cm. Example 2. A circular playground has a circumference of 72.6 meter. Find its radius and diameter. Given. C is equal to 72.6 meter. To find D is equal to question mark, R is equal to question mark. Solution. Since circumference is already given, we will use the formula C is equal to pi into diameter. Therefore, 72.6 is equal to 22 upon 7 into diameter. Interchanging the sides, we get D is equal to 72.6 into 7 upon 22, which is equal to 3.3 into 7. Therefore, D is equal to 23.1 meters. We know radius is equal to diameter divided by 2. Therefore, radius is equal to 23.1 upon 2. Therefore, radius is equal to 11.55 meters. Answer is diameter of the playground is 23.1 meters and radius is equal to 11.55 meters. Example 3. The radius of a circular garden is 56 meter. It is to be fenced with 4 rounds of wire. If the wire costs rupees 40 per meter, what is the cost of fencing? Given is radius of circular garden, which is equal to 56 meter. We can calculate its circumference. Solution. By using C is equal to 2 into pi into r. Therefore, C is equal to 2 into 22 upon 7 into 56. That is, C is equal to 2 into 22 into 8. Therefore, circumference is equal to 352 meter. Now, next given is that the garden has to be fenced with 4 rounds of wire. From the given data, we understand that 1 round of fence requires 352 meter wire. 4 rounds of fence will require 352 into 4, which is equal to 1408 meter wire. Also given that the cost of 1 meter of wire is equal to rupees 40. Total cost of fencing is equal to 1408 into 40, which is equal to rupees 56,320. Answer. Total cost of fencing of the circular playground is rupees 56,320. Example 4. The diameter of a bullock cart wheel is 1.4 meter. How many times must the wheels rotate for the cart to cover a distance of 1.1 kilometers? Given. Diameter of wheel is equal to 1.4 meter. Distance to be converted is equal to 1.1 kilometer. Solution. Remember to convert all units for simple calculation. In this example, we will convert kilometer into meter. As 1 kilometer is equal to 1000 meter, therefore 1.1 kilometer is equal to 1.1 into 1000, which is equal to 1100 meter. Now we will first calculate the circumference of wheel. Circumference of the wheel is equal to 1 rotation of wheel. Therefore, circumference is equal to pi into diameter. Therefore, C is equal to 22 upon 7 multiplied by 1.4, which is equal to 4.4 meter. Therefore, circumference of wheel is equal to 4.4 meter. You must be wondering as to why we first calculated the circumference of wheel, though it is not asked in the problem. Your doubts will be cleared as I explain it further. Total number of rotation is equal to distance upon circumference of the wheel. Therefore, 1100 divided by 4.4, which is equal to 1100 into 10 upon 44, which is equal to 250 rotation. So, the answer is the wheels must complete 250 rotations for the cart to cover a distance of 1.1 kilometers. Now we see How to calculate area of a circle? We first draw a circle. Cut out this circular part along the circumference, as shown in the figure. It is the region bounded by the circumference of the circle. The measure of this region is called the area of a circle. The area of a circle is calculated using the formula as follows. Area of circle is equal to pi into radius square. Let us solve few examples. Example 1. Find area of a circle if its radius is 2.1 meter. Solution. Since radius is given as 2.1 meter, we can use the formula A is equal to pi into radius square. Area is equal to 22 upon 7 into 2.1 into 2.1 is equal to 22 into 0.63 is equal to 13.86 square meter. Now let us solve another example in which we have to find the radius and diameter of a circle whose area is given. Example 2. The area of a circular playground is 3850 square meter. What is its radius and diameter? Given. Area of circular playground A is equal to 3850 square meter. We have to find radius and diameter. Solution. As we know, area of circle is equal to pi into radius square. Therefore, 3850 is equal to 22 into 7 multiplied by radius square. Therefore, radius square is equal to 3850 multiplied by 7 upon 22. Dividing 3850 by 22, we get radius square is equal to 175 multiplied by 7. Writing factors of 175, we get radius square is equal to 5 into 5 into 7 into 7. Now taking square root of both the sides, therefore radius is equal to 5 into 7. Therefore radius is equal to 35 meter. Since diameter is equal to 2 into radius, therefore diameter is equal to 2 into 35, which is equal to 70 meters. Therefore, radius of circular playground is equal to 35 meter and diameter is equal to 70 meter. Now let us solve exercise 29. Example 1. The circumference of a circle is 96.8 meters. Find its area. Given. Circumference of circle is equal to 96.8 meter. Solution. To find the area of a circle, we should know its radius. But here only circumference is given. But we know that circumference is equal to 2 into pi into r. Therefore, 96.8 is equal to 2 into 22 upon 7 into r. 96.8 into 7 upon 22 into 1 upon 2 is equal to r. R is equal to 96.8 into 7 upon 44. Dividing 96.8 by 44, we get the quotient as 2.2. Therefore, radius is equal to 2.2 into 7. Radius is equal to 15.4 meter. Now we can calculate area of circle. Area of circle is equal to pi into radius square. Area of circle is equal to 22 upon 7 into 15.4 into 15.4. Area is equal to 22 into 33.88. Area is equal to 745.36 square meter. Answer. Area of circle is equal to 745.36 square meter. Example 2. See the figure on the screen. length of AB is equal to 14 centimeter. If the diameters of the semicircles AM and MB are equal, what is the total area of the shaded part? Given two semicircles with diameters AM and BM. Length of AM is equal to length of BM. Also, the length of AB is equal to 14 centimeter. We have to find the area of shaded part of both the semicircles. Solution. Length of AB is equal to 14 centimeter. Therefore, length of AM is equal to length of BM is equal to length of AB divided by 2. Therefore, length of AM is equal to length of BM is equal to 14 divided by 2 is equal to 7 centimeter. Thus, diameters of both semicircles are 7 centimeter. So, to find out the area of shaded part, we should know its radius. We got diameter of both semicircle is equal to 7 centimeter. Therefore, radius of semicircles is equal to diameter upon 2 is equal to 7 upon 2 centimeter. So, according to data, we can conclude that two semicircles make one circle. Therefore, area of two semicircles is equal to area of one circle. Therefore, area of a circle is equal to pi into radius square. 22 upon 7 into 7 upon 2 into 7 upon 2. By reducing, we get area of a circle is equal to 77 upon 2 is equal to 38.5 square centimeter. Thus, area of the total shaded part is equal to area of one circle is equal to 38.5 square centimeter. The arc of a circle. A circle is a shape with no vertices, no sides and no angles. What do you mean by the arc of the circle? An arc of the circle means a part of the circumference. For example, in this figure, we shall try to name the different arcs formed by the points A, B and C on the circle. When you take points A and B, we can see that an arc AXB is formed as X lies on the circle between the 2 points A and B. When you take points B and C, we can see that an arc BYC is formed as Y lies on the circle between the 2 points B and C. When you take points A and C, we can see that an arc AZC is formed as Z lies on the circle between the 2 points A and C. Now we shall learn about that. Intercepted arc. What do you mean by an intercepted arc? Intercepted arc is the arc which is formed by an angle on the circle. In other words, when an angle cuts the circle, the arc derived is known as the intercepted arc. In this figure, as point N of the arc NTS lies on side ON of angle NOS, and the point S of arc NTS lies on side OS of angle NOS, we can say that angle NOS intercepts arc NTS. Similarly, as point N of the arc NTS lies on side ND of angle NDS, and the point S of arc NTS lies on side DS of angle NDS, we can say that angle NDS intercepts arc NTS. Let us now try to solve few sums. 1. In the figure, name the angles which intercept the arc LXT. In this figure, as point L of the arc LXT lies on side LN of angle LNT, and the point T of arc LXT lies on side NT of angle LNT, we can say that angle LNT intercepts arc LXT. Similarly, as point L of the arc LXT lies on side LM of angle LMT and the point T of arc LXT lies on side MT of angle LMT, we can say that angle LMT intercepts arc LXT. Therefore, angle LMT and angle LNT intercept the arc LXT. 2. Observe the figure and name the angles which intercept arcs and name the arc that each angle intercepts. Taking angle AOB. In this figure, as point B of the arc AXB lies on side OB of angle AOB and the point A of arc AXB lies on side OA of angle AOB, we can say that angle AOB intercepts arc AXB. Taking angle BOC. In this figure, as point C of the arc BYC lies on side OC of angle BOC and the point B of arc BYC lies on side OB of angle BOC, we can say that angle BOC intercepts arc BYC. Taking angle AOC. In this figure, as point A of the arc AZC lies on side OA of angle AOC and the point C of arc AZC lies on side OC of angle AOC, we can say that angle AOC intercepts arc AZC. What do you mean by the diameter of a circle? A line which cuts the circle in exactly two halves is known as the diameter. In this figure, as AB cuts the circle in exactly two halves, we can say that it is the diameter of the circle. What do you mean by a chord of a circle? The line segment joining any 2 points of a circle is called chord of a circle. In this figure, AB is a chord of a circle. There are 3 types of arcs of a circle. They are 1. Minor arc, 2. Major arc, 3. Semicircular arc. What is a minor and major arc? Look at the figure on the screen. In this figure, as you see that AB is not a diameter, it is a chord, which divides the circle into 2 halves which are not equal. We have 2 arcs, arc AXB and arc AYB. Therefore, we can say that arc AXB is the minor arc of the circle as it is small in size, and the arc AYB is the major arc of the circle as it is big in size. Now we shall learn what is a semicircular arc. Look at the figure on the screen. In this figure, as you see, that RT is a diameter which divides the circle into exactly 2 halves. We have 2 equal arcs, arc RYT and arc RXT. Therefore, we can say that arc RYT and arc RXT are semicircular arcs. Let us solve a few sums. 1. In the figure, segment SD and segment TN are diameters. Name those minor arcs, major arcs and semicircular arcs whose endpoints are also the endpoint of the diameters. Minor arcs are arc SYN, arc NMD, arc DZT and arc TXS. If we join 3 continuous minor arcs in the given figure, we will get major arc. So, major arcs are arc SMT, arc TYD, arc DXN and arc NZS. SD and TN are the diameters of a circle. So we get two semicircular arcs with diameter SD and same with the diameter TN. So semicircular arcs are arc SZD, arc SYD, arc TXN and arc TZN. We shall now learn what is a central angle and the measure of the arc. What do you mean by a central angle? An angle having the center of the circle as its vertex is called a central angle. As you can see, the angle POQ is formed having the vertex O, which is the center of the circle. We can say that the angle POQ is the central angle of the circle. Now we shall learn about the measure of the arcs. Let us look at certain very important and necessary points while finding the measures of the different arc of the circle. 1. The measure of the entire circle is 360 degree. 2. The measure of the central angle is equal to measure of its corresponding minor arc. 3. The measure of the major arc is equal to 360 degree minus the measure of the minor arc. Let us solve an example based on the measures of the arc. 1. Observing, we know that angle AOB is a central angle which is equal to 100 degree. Secondly, arc AXB is the minor arc and arc AYB is the major arc. Now let us find the measures of both the arcs, the minor and major. First, let us find the measure of the minor arc AXB. The measure of the minor arc will be equal to the measure of the central angle. Therefore, the measure of minor arc AXB is equal to the measure of the central angle AOB is equal to 100 degree. Now we shall find the measure of the major arc AYB. The measure of the major arc is equal to 360 degree minus the measure of the minor arc. Therefore, the measure of the major arc, that is arc AYB, will be 360 degree minus the measure of the arc AXB, which is equal to 360 degree minus 100 degree, which is equal to 260 degree. Therefore, the measure of the major arc AYB is equal to 260 degree. Now we shall learn how to find the measure of a semicircular arc. As you all know, the diameter cuts the circle into two equal halves. Thus, we have two equal semicircular arcs. The measure of the circle is 360 degree. Therefore, the measure of the semicircular arc is equal to 360 degree divided by 2, that is 180 degree each. Hence, in our figure, the measure of two semicircular arcs, arc AXB and arc AYB, is equal to 180 degree. 2. In the figure, segment PN and segment TC are the diameters of the circle. Write the measures of the arcs formed by the endpoints of these diameters and explain your answer. Given, measure of angle POT is equal to 100 degree. Segment TC and segment PN are diameters of the circle. First, take all the minor arcs. First, we shall consider diameter TC. As you all know, the measures of angles in a linear pair is equal to 180 degree. Angle POT and angle COP are angles in a linear pair. Hence, the sum of these two angles will be 180 degree. Therefore, measure of angle POT plus measure of angle COP is equal to 180 degree. As it is already given that the measure of angle POT is equal to 100 degree, we shall substitute it in our equation. Therefore, 100 plus measure of angle COP is equal to 180 degree. Hence, measure of angle COP is equal to 180 degree minus 100 degree, which equals to 80 degree. Hence, measure of angle COP is equal to 80 degree. So we have the measure of angle POT is equal to 100 degree and measure of angle COP is equal to 80 degree. I hope you remember the rule that vertically opposite angles measure the same. And as per this rule, angle POT and angle CON are vertically opposite angles and hence they will measure the same. Therefore, as the measure of angle POT is equal to the measure of angle CON is equal to 100 degree. Similarly, angle COP and angle TON are vertically opposite angles and hence they will measure the same. So, measure of angle COP is equal to measure of angle TON. The measure of angle COP is 80 degree. Therefore, the measure of angle TON will also be 80 degree. Now, finally we have the measure of all the angles. The measure of angle POT is equal to 100 degree. The measure of angle COP is equal to 80 degree. The measure of angle CON is equal to 100 degree. And the measure of angle TON is equal to 80 degree. We have found the measure of all the angles. But we want to find the measure of all the minor arcs. Arc PXT, arc TYN, arc CZN and arc PWC. As the measure of the minor arc is equal to the measure of its corresponding angle, the corresponding angle of arc PXT is angle POT. Since the measure of angle POT is 100 degree, the measure of arc PXT will also be 100 degree. The corresponding angle of arc TYN is angle TON. Since the measure of angle TON is 80 degree, the measure of arc TYN will also be 80 degree. Similarly, the corresponding angle of arc CZN is angle CON. Since the measure of angle CON is 100 degree, the measure of arc CZN will also be 100 degree. The corresponding angle of arc PWC is angle COP. Since the measure of angle COP is 80 degree, the measure of arc PWC will also be 80 degree. Now we shall find the measure of all the major arcs. That is, arc PYC, arc PZT, arc TWN and arc CXN. The measure of a circle is 360 degree. The major arc PYC and the minor arc PWC forms the entire circle. So, measure arc PYC plus measure arc PWC is equal to 360 degree. Therefore, measure of arc PYC is equal to 360 degree minus measure arc PWC. That is, measure of arc PYC is equal to 360 degree minus 80 degree. Hence, the measure of the major arc PYC is equal to 280 degree. In the same manner, we will find the measure of other major arcs. Hence, the measure of the major arc PZT is equal to 260 degree. The measure of the major arc TWN is equal to 280 degree. The measure of the major arc CXN is equal to 260 degree. Now we shall learn what you mean by inscribed angle. What do you mean by an inscribed angle? Look at the figure. In this figure, O is the center of the circle. Point M and point S are the endpoints of arc MTS. Point M and point S are on the sides of an angle MTS. Vertex T of angle MTS is on the arc MTS. Therefore, we can say that angle MTS is an inscribed angle in the arc MTS. Let us solve a few sums. 1. Observe the given figure and fill in the blanks. Angle PML is inscribed in the arc PML and angle TNL is inscribed in the arc TNL. 2. Draw a circle. Show an arc LMN on this circle. Inscribe angle LMN in it. How many more angles can you inscribe in this arc? The figure shows arc LMN on the circle. As a circle has infinite points, infinite angles can be inscribed in the arc LMN. Now we shall learn the relation between the inscribed angle and intercepted angle. Remember that the measure of the inscribed angle is always half the measure of the arc intercepted by it. Look at the figure. In this figure, angle APB is inscribed in arc APB. Measure of angle APB is equal to 55 degree. The inscribed angle APB intercepts arc AXB. Angle AOB is the corresponding central angle of arc AXB. Therefore, the measure of angle AOB is equal to measure of arc AXB. The measure of angle AOB is equal to 110 degree. Therefore, the measure of arc AXB will also be equal to 110 degree. Thus, this proves that the measure of the inscribed angle APB is half the measure of intercepted arc AXB. Let us solve few sums. 1. The measure of a central angle is 120 degree. Find the measures of the arc it intercepts. Given, the measure of the central angle is equal to 120. As the measure of the central angle is equal to the measure of the intercepted arc, therefore, the measure of the arc it intercepts is equal to 120. The measure of the intercepted arc is equal to 120 degree. 2. In the figure, arc AXB is a semicircle. Measure of angle PAB is equal to 40 degree. Find the values of 1. Measure of angle APB. 2. Measure of arc PYB. 3. Measure of arc AZP. Given, measure of angle APB is equal to 40 degree and arc AXB is a semicircle. For angle APB, as said that arc AXB is a semicircular arc and we all know that a semicircular arc measures 180 degrees. Therefore, the measure of arc AXB is equal to 180 degrees. As you can see in the figure, angle APB is inscribed in the arc APB. Arc AXB is an arc intercepted by it. Therefore, its measure will be half the measure of the intercepted arc. Therefore, measure angle APB is equal to half of measure arc AXB, which is equal to half into 180 is equal to 90 degree. Therefore, measure angle APB is 90 degree. For arc PYB. Now let's find measure arc PYB. As you can see in the figure, angle PAB is inscribed in the arc PAB. Arc PYB is an arc intercepted by it. Therefore, its measure will be half the measure of the intercepted arc. Therefore, measure angle PAB is equal to half of measure arc PYB. By substituting, we get 40 is equal to half measure arc PYB. Therefore, measure arc PYB is equal to 40 into 2 is equal to 80 degrees. Therefore, the measure of arc PYB is equal to 80 degrees. For arc AZP, we still have to find the measure of arc AZP. We know that arc AXB is a semicircle. Therefore, AB is the diameter of the circle. Hence, arc APB is also a semicircle. So, measure arc AZP is equal to 180 degrees minus measure arc PYB is equal to 180 minus 80 is equal to 100 degrees. Therefore, the measure of arc AZP is equal to 100 degrees. Now we shall learn what do you mean by a cyclic quadrilateral. Let us consider the figure on the screen. As you see, the vertices of a quadrilateral B, S and L are on the circle. Such a quadrilateral is called a cyclic quadrilateral. In other words, a quadrilateral is said to be cyclic if all its four vertices lie on a circle. Remember, the opposites angle of a cyclic quadrilateral are supplementary. In the figure, measure of angle B plus measure of angle N is equal to 180 degree. Measure of angle S plus measure of angle L is equal to 180 degree. Let us solve sums. 1. In the figure, measure of angle B is equal to 85 degree and measure of angle C is equal to 105 degree. Find measure of angle A and measure of angle D. Given. Measure of angle B is equal to 85 degree, measure of angle C is equal to 105 degree. For measure of angle A, as said earlier, measure of the opposite angles of a cyclic quadrilateral are supplementary. Hence, the measure of angle A plus measure of angle C is equal to 180 degree. Substituting, we get measure of angle A plus 105 degree is equal to 180 degrees. Keeping measure of angle A on one side, we get measure of angle A is equal to 180 degree minus 105 degrees. Measure of angle A is equal to 75 degrees. Therefore, measure of angle A is equal to 75 degrees. For measure of angle D, similarly, measure of angle D plus measure of angle B is equal to 180 degree. Substituting, we get measure of angle D plus 85 degree is equal to 180 degrees. Keeping measure of angle D on one side, we get measure of angle D is equal to 180 degree minus 85 degrees. Measure of angle D is equal to 95 degrees. Therefore, measure of angle D is equal to 95 degrees. 2. The measures of the opposite angles of a cyclic quadrilateral are x and 3x. What are the measures of these angles of the quadrilateral? Given. One angle is equal to x. Its opposite angle is 3x. The opposite angles of a cyclic quadrilateral are supplementary. Therefore, the equation will be x plus 3x is equal to 180 degrees. 4x is equal to 180 degrees. Therefore, x is equal to 180 degrees divided by 4, which is equal to 45 degrees. Hence, as one angle is x, its measure will be 45 degrees, and the measure of other angle is 3x, that is 3 into x. Therefore, its measure will be 3 into 45, which is equal to 135 degrees. The measures of the opposite angles of a given quadrilateral are 45 degrees and 135 degrees respectively.